down-hole full-bore infinity stage sliding sleeve system. Today, let's get to know a completely new tool system. Unconventional natural gas resources have today become a key growth point for natural gas production. According to EIA forecasts, by 2030, unconventional gas resources will comprise 77% of U.S. natural gas output, of which tight gas will account for 21%, coal bed methane 7%, and shale gas 49%. Unconventional oil and gas reserves in China are immense and growing rapidly. In 2014, the China Academy of Engineering calculated that China's recoverable tight gas reserves were 9 to 13 trillion cubic meters, with plans to reach 80 to 120 billion cubic meters in production volume by 2030. The National Energy Administration calculated in 2015 that China's recoverable shale gas reserves were 25 trillion cubic meters, and it is expected that a production volume of 80 to 100 billion cubic meters will be reached by 2030. In order to achieve high-efficiency exploration and development of these unconventional resources, the innovation and development of engineering technology is particularly important. Today, we bring an innovative tool system with fully independent intellectual property rights, which will bring a technical revolution in the field of high-efficiency development of unconventional resources. It combines the four major functions of unlimited stages for multi-stage stimulation, post-fracturing tubing string full bore, switchable single stage, and tubing integration, and can be widely applied to oil wells, gas wells, unconventional and conventional reservoirs. In general, it encompasses well completion, reservoir stimulation, and oil and gas production industrial links. At present, we have applied for 15 national invention patents and have been awarded 8 authorized invention patents and 12 utility patents. 8 invention patents have already reached the stage of substantive review. We have also applied for 3 invention patents and completed application for patents in 8 countries, including the US and Russia. We have already obtained patent authorizations in Russia and Kazakhstan. A completely new tool with a simple and elegant technological process. This tool system is comprised primarily of 3 components: external and internal tubes and a switching tool. It possesses a unique and ingenious structure. Following the completion of oil and gas wells, the tool's multi-stage simulation tubing string tripped in just once. Pressure is added to the tubing and all packers are set just once. A switch tool is thrown into the well, and because the switch tool and the slide sleeve possess unique compatibility, the tool will independently perform compatibility assessments during the pumping process, as well as automatically lock the targeted sliding sleeve. When the tubing pressure increases, the sliding sleeve is triggered and thus performs first-stage fracturing work. Following the completion of first-stage work, the second switch tool is added to re-perform the work process at the next section and complete reservoir stimulation at the second section. The process continues until operations are completed at all sections. When there is a flowback of fracturing fluid in the well, the tool system's dissolvable balls dissolve while the tubing flow channel connects automatically. On the basis of need, the specialist salvage tool is inserted to maneuver the entire switching tool to the bottom of the well or retrieve it from the well. The tubing can achieve full bore, which is of benefit to subsequent production or downhole operations. The functionality of the system is strong and its advantages are readily apparent. The advantages: 1. No limit to the number of stages. When the tool is confined by space limitations, an innovation in numerical code theory and methods achieves limitless code combinations, breaking through the technical bottleneck of limitations on the number of tool stimulation stages. When it comes to comparatively conventional multi-stage techniques, the tool adopts a full-bore unlimited slide sleeve system, achieving greater simulation of reservoirs. This achieves an effective increase in the output volume and stable production capability of individual wells. Advantage 2. Tubing full bore following stimulation. The conventional ball-activated sliding sleeve changes paths at each stage, which creates flow throttling and the problem of greatly reduced pressure. The realization of a full bore removes the impact of paths changes and tubing flow becomes smoother. It also resolves the dilemma of conventional techniques, which are unable to perform production logging in horizontal sections. It makes well conditions smoother and provides a technological safeguard for a high-efficiency production and management of oil and gas wells. Advantage 3. Individual sections become switchable. During the production process, water can emerge at any section, and by means of the switch tool, it is possible to fix closure at sections where water has emerged. During subsequent stages, it is possible to perform further opening or closing based on requirements. Advantage 4. Easy and convenient use of technology. By means of a tubing string, it is possible to achieve stimulation of all sections. Following the completion of stimulation, the oil or gas well can directly commence production. Advantage 5. The tool's functions are stable and reliable. The sliding switch components passed 40 fatigue stress of between 0 to 70 MPa. Individual components have passed high-pressure sandblasting assessment tests, and the tool's resilience capability is exceptional. At temperatures of 120 degrees Celsius and under 70 MPa, the tool has successfully passed 62-ton tensile assessment. The tool system's full functionality is outstanding. By means of authoritative assessment performed by a specialist team of Academy members, the tool system's unlimited stage code design method, launch components, and sliding sleeve structure have all achieved leading international well levels. It combines the 4 major functions of unlimited stages, switchable feature, full bores, and full integration. It possesses the outstanding advantage points of low cost, a brief operation cycle, and reliable and stable functionality. The full functionality and capabilities of the tool system are markedly superior to similar overseas and domestic products. In 2014, the tool had been fully promoted and adopted with mature and reliable stability. The tool follows 4 years of innovative research and development. In 2011, the initial idea was first proposed and research and development commences. By 2014, the research and development process proved successfully with full promotion and usage on site. By 2016, the tool's application had reached a high level, achieving successes in the stimulation and horizontal section logging of 30 stages of the Jingsha 33-19 well. Over the past 3 years, been used at West Sichuan tight sandstone gas deposit with wells in 22 occasions on 266 sections. The success rate is 100%. The Jingsha 33-13 well has a depth of 4,418 meters and horizontal sections that are 1,600 meters in length. After a period of 58 hours, the tool achieved fracture stimulation at 30 sections, breaking a new world record when it comes to immobile tubing string tubing fracturing. The technology achieves an increase in well output and outstanding stable production results. The average tested output was 60% greater than conventional technologies, and the stimulation cycle was 40% shorter than other full-bore fracturing technologies, such as dissolvable bridge plugs and through-coil tubing fracturing. It will solve our difficulties, increase the efficiency of your management, and bring you a high efficiency. This tool system can be broadly applied to conventional and unconventional oil and gas reservoir fracking stimulation operations, and in addition to being able to replace conventional horizontal well fracking tools, its enhanced stage capability is of benefit to resolving the exploring problem of hard mobilized reserves. In single stages, it is possible to simultaneously achieve switchability and well full bore, which can be used for the single-stage evaluation of different well types, section-by-section assessments, and multi-section development, satisfying the needs of multiple exploration and development models. The application and well conditions for this tool are excellent, and production and management will become more effective. The full-bore well capability resolves the problem of horizontal well production logging and provides conditions for scientific decision-making when it comes to accurate assessment of stage output and production management. With regard to those gas wells where water emerges, it is possible to perform fixed closure of stages where water emerges and avoid the emergence of water in the sections from affecting production. This guarantees the long-term stability of gas production. The flexibility of the tool permits the re-performance of the switching function, which resolves the persistent difficulty of late-stage ponding following oil reservoir production, and is of benefit to the performance of ponding profile control. In terms of costs, the usage of tool system involves no additional procedures or fees. It enriches production management measures and methods and will bring pronounced economic benefits. The system's ingenious structure, excellent functionality, and stable capabilities have seen it widely promoted and applied in major oil and gas fields in North China, Northwest China, and East China, as well as in the Middle East, North America, and South America.